Molecular geometry and polarity. Problem. The problem is difficulties in predicting the 3D image of the molecular geometry. The objective of this video is to guide students on molecular geometry and polarity with the help of 3D models and to improve their understanding on this particular topic.
Introduction to valence shell electron pair repulsion or VSEPR theory. First, molecules are contained from three-dimensional objects. And second, although Lewis structures show which atoms are connected to which and even provide a basis estimate the distances between bonded atoms, but they also reveal nothing about the way the atoms are situated in space. And third, an extension of Lewis' theory is required to predict the angles defined at an atom by two or more covalently bonded neighbors.
FIESTA theory, used to predict the molecular shape for the covalent molecules and polyatomic ions. In predicting the molecular shape, double or triple bond is treated as single bond. The bonding pairs and lone pairs electrons repel to one another and arrange themselves as far apart as possible to minimize the repulsions. Only sigma bonds contribute to the shape of covalent molecules and polyatomic ions. How to draw the Lewis structure? First, we have to count total number of valence electrons. Next, we have to determine the terminal and central atom. After that, we have to connect atoms with a single bond. Then, we have to complete octet terminal atom. Finally, we have to fill electron in central atom.
How to predict molecular geometry based on the FIESTA theory? First, write electronic configuration. Second, draw the Lewis structure of the molecule or ion. Third, state the number of the electron pairs and assign the electron pairs geometry around the central atom. Fourth, predict the bond angle and the direction of any deviation due to the effect of lone pairs. Lastly, draw and name the molecular geometry.
There are 5 basic molecular geometry, which are linear, trigonal planar, tetrahedral, trigonal bipyramidal, and lastly octahedral.
After we know about how to draw the Lewis structure and also know about the molecular geometry, and we know about the molecular polarity.
All you can see is the model of AlCl3. This is the center atom Al, and this 3 atom is Cl atom.
The question will ask about how to predict the shape of AlCl3. Okay, first of all, you need to draw the table that contains of number of valence electrons, bonding pair electrons, lone pair electrons, electron pair geometry, molecular geometry, and also bond angles. To know how to draw the Lewis structure, so you need to know the valence of electron of each atom. For Al, we get 3 electrons, while for Cl, times by 3 atoms, so we get the 21 electrons. So the total of electrons will be get the 24 electrons. Because at here you can see that around of Al it contain of 3 of bonding pair electrons, which is 1, 2, and also 3. While for lone pair electrons is 0 because do not have any lone pair electrons around of Al atom. And for electron pair geometry is trigonal planar. So the molecular geometry is also the trigonal planar. So the bond angles is 120. This is the molecular geometry of AlCl3, that is trigonal planar. From the video, we can see the Al atom cannot be moved. It is because Al pulled by the 3Cl atom, so it will form the polar bond. So we will cause the bond dipole cancel each other. So we can write as mu equal to 0. So AlCl3 is a non-polar. So student can draw the cross-based arrow from the less electronegative atom to the more electronegative atom. So as we can see here that people can draw the cross-based arrow from Al to Cl atom.